Alrighty, let's take a look at this guy. Because our first step is, let's go 5 and 6. That's 11. Those are just series, right? And then these guys are parallel. So that's an 11 and a 17 in parallel. So that is going to be left parenthesis 11 to the minus 1 plus 17 to the minus 1, right parenthesis to the minus 1. That is 6.78, 6.6786 roughly. Okay. And now we've got a series thing going on here, right? So that's 2 plus 3 plus this guy plus 4, right? So let's do that. 2 plus 3 plus the guy I just got, the 6.6786. I just pop that in there and then plus 4. Use the up arrow. That's 15.6786 ohms. And now that is in parallel with this guy here. Okay. So that is going to be 11 plus 15.76786 to the minus 1 to the minus 1. What is that? Left parenthesis, 11 to the minus 1 plus, and then I'm going to pop that number in there to the minus 1, right parenthesis to the minus 1. And that is 6.4645 ohms. And now we can solve it. 43 volts pushes in a series circuit current through a 3, a 6.4645, and a 2, right? So now I can figure out A1. A1 is just V over R, and that is 43 divided by a 3, right? Plus 6.4645 plus 2. So let's figure that out. 43 divided by left parenthesis 3 plus the number I just got plus 2 right parenthesis. That is 3.7507. All right. Okay, so we got that guy. Let's see what else. What does that let us figure out? The current. Do they ask for the current through this or this? They don't, because it would be the same as that. Okay, or the voltage across? No. Okay, now let's figure out V1. V1 is going to be IR. All voltages are IR. But which I and which R, right? That's the question, right? And the current will be this current, right? So that current is going through, and we're going to pretend that this whole side is one resistor with this value, right? So it's going to be 3.7507 times 6.4645. Okay, so that number that's on my calculator, boom, times, I got to find another number. There it is. So I use the up arrow on my calculator to find these. Wow, that's a cool number. 24.246499696. Interesting. All right. That is 24.2465 volts. All right. What does that let us do? Oh, now we can figure out the current through the 11. Let's do that. And then the current through the 4 ohm, right? The current through the 4 ohm is the current going through this mass, and through this. All right, so let's figure those out. So let's go current for the 11 ohm. And that's just simply going to be V1 divided by 11. Right, so it's 24.2465 over 11. The number I just got out divided by 11. That's all I'm doing. So 2.2042. That's my current through the 11 ohm. All right. All right. This guy's going to be more useful. So the current through this whole side here, which is also the current through the 4 ohm, right? Let's figure that guy out. So I4 ohm is equal to V1 divided by, what's this whole resistance? This whole resistance on this side was this, 15.6786, right? So that equals, V1 is 24.2465 divided by 15.6786. Let's find that. There it is. That's that guy divided by, now I got to find the 15 number. There it is. And I'm getting that that is equal to 1.5465 roughly amps. 1.5465. Hey, we're getting them right. This is good. It's good news. Okay. I'm looking at the spreadsheet just to make sure. All right, let's see. Well, that's 4 ohms. Okay. Okay, so now we can find V2 and V3 because we know what this current is, and those voltages will be IR. So V2 is IR, and it's this current. The same current that goes through the 4 ohm is also going through the 2, through the 3, through this mess, and through the 6, right? So it's this current, 1.5465. And then this resistance for V2 is just 2, right? So that guy times 2. That's 3.0929 volts. That's V2. That's not a helpful voltage, it's just we got one of the answers. Okay, so let's see. V3 is going to be very helpful. We're going to use V3 quite a bit. V3 is IR as well. And then what current? Well, it's the same current, right? 1.5465. And then what's our resistance in the path of that? I think it's this, right? It's the 6.6786. Okay. Boom. Times you gotta find it. Where is it? Oh, there it is. That's it. I got it. I got it. I got it. All right, here we go. Ready? And that is 10.3282 volts. Did we get it right? We did. That's V3. And we're going to use this. This guy is going to help us get down into this bit here, right? Okay. 10.3282 volts. Okay. So now we can get into these guys. We can get all of this stuff, right? Because the 5 is down in this circuit. The 17 is in there, right? The voltage across the 6 ohm, right? We can do all these things. All right, so let's see. Let's find the voltage, the current through the 5 ohm. I5 ohm is equal to, what is that? That is going to be V divided by R. And specifically, it's going to be V3 divided by, and in this path right here, there's 11 ohms, right? So it's going to be 10.3282 divided by 11. The number I just got divided by 11. And that is 0.9389. And that is amps. Did we get that right? We did. Ooh, look at us. We are good. Okay, so hold on here. So now we want to figure out the current through the 17 ohm, and that's going to be the same voltage, right, is pushing current through 17 ohms. So I 17 ohms is going to be V3 divided by, well, just 17, right? So it's going to be 10.3282 divided by 17. That's a 2. Just didn't get a chance to be. So that guy divided by 17. And that is 0.6075 amps. Okay, notice that this current and this current add up to the current through the 4 ohm. If you add this guy and this guy, you're going to get this, right? Which is the main current on this whole side. Okay, so I-17 ohms is 0.6075 amps. And then finally, we want to find the voltage across the 6 ohm. Okay, so the voltage across the 6 ohm is always IR, but we just got to figure out what I and what R, right? R is easy. R is 6 ohms, right? But what current was going through here? I think we figured it out. That's the current that's going through the 5 ohm also goes through the 6 ohm, right? Because they're series. There's just one current there, right? So that's going to be, what is that going to be? What is that current? Current through the 5 ohm is 0.9389. And then it's times 6 ohms because that's the potential there. Okay, I got to find that. Oh, there it is. Boom, divided, multiplied by 6. And that is 5.6336 volts. Okay. Oh, we didn't use the whole screen here. Wow, look at you. I have enough room to draw a pretty pony. Look at that. You just watched me draw a pretty pony. There. Ooh, that's a really good horse, I think. It could be a pony. Did I answer all the questions? Did I get them all right? What are the odds? Wow, I'm impressed. All right,